In this video, we will discuss the hypothesis test for one population mean when sigma is unknown. A hypothesis test for a population mean when the population standard deviation sigma is unknown is conducted in the same way as if the population standard deviation is known. The only difference is that the t-distribution is invoked instead of the standard normal distribution, J distribution. This hypothesis testing procedure is called one-mean t-test or simply t-test. We have formally introduced t-value in Module 3. Again, if the population standard deviation is not known, S is substituted for sigma. The test statistic is the t-distribution. The degrees of freedom is given by n-1, where n is the sample size. We can use a t-table to check for the t-value. We start with this one-tail test, a left-tail test. Again, we use the 6-step hypothesis testing procedure. I will first give you the background information of this case. The Myrtle Beach International Airport provides a shell phone parking lot where people can wait for a messenger to pick up arriving passengers. To decide whether the shell phone lot has enough parking place, the manager of the airport wants to know if the mean time in the lot is more than 15 minutes. To do so, they collect a sample of 12 recent customers to know about the waiting time in the lot. These are the waiting times of these customers. The question is, at a 0.05 level of significance, is it reasonable for us to conclude that the mean waiting time in the lot is more than 15 minutes? Following the 6-step hypothesis testing procedure, the first step is we state the null hypothesis and the alternative hypothesis. Because we would like to know whether if the mean time in the lot is more than 15 minutes, it is appropriate to set the null hypothesis as mu less or equal 15. And the alternative hypothesis is mu larger than 15. The level of significance has been preset at 0.05. Given that sigma is unknown, we will use t-value as the test statistic. Because this is a one-tail test, we find the row at the top label level of significance for one-tail test. Given that the sample size is 12, we have the degrees of freedom as 12 minus 1 equal to 11. The value at the intersection is 1.796, which we serve as the critical value of the rejection region. In step 5, we calculate the sample mean and sample standard deviation, which is given by x bar equal to 23, s equal to 9.835. We then calculate the test statistic as follows: t equal to x bar minus mu over s divided by square root of n equal to 23 minus 15 over 9.835 divided by square root of 12, which is equal to 2.818. Because the test statistic of 2.818 is greater than our critical value of 1.796 in the rejection area. Therefore, our decision is reject H sub 0. In conclusion, the time customers spent in the lot is more than 15 minutes. This result indicates that the airport may need to add more parking places. We now investigate a two-tiered test. In this small case, the average cost of a hotel room in New York is set to be $168 per night. To determine if this is true, a random sample of 25 hotels is taken and resulted in an X bar of 172.5 and a standard deviation of 15.4. Our goal is to test the approximate hypothesis at alpha equal to 0.05. So the first step is to set the non-hypothesis as mu equal to 168. The level of significance is given at 0.05. In step 3, we decide to use the t-test because the standard deviation is unknown, and we are going to use the sample standard deviation S. In step 4, in the t-table, we find the intersection point of the two-tail 0.05 level of significance level, and the degrees of freedom of 25 minus 1 equal to 24, then we obtain the t-value at 2.0639, which is the critical value of the right-hand side rejection area. The critical value of the left-hand side rejection region is negative 2.0639. In step 5, we compute the t statistic, which is given by t stat equal x bar minus mu over s divided by square root of n equal to 172.5 minus 168 over 15.4 divided by square root of 25, which is equal to 1.46 at about this location of this graph. Given that the t-stat is inside the do not reject region, we do not have sufficient evidence that the true mean cost is different from $168 and cannot reject the long hypothesis. Now, please let us revisit the case of female salary. We have examined this case from the perspective of confidence interval in Module 3. In this case, as we previously mentioned, some board members of Artsy Corporation are concerned with the issue that women are being discriminated in the company. One board member is convinced that the mean salary for the men is £66,300. Based on the sample of 26 female workers, we know that average female salary equal to £62,577. The standard deviation is equal to £7,337. The standard error is given by 7,337 divided by square root of 26 equal to 1,439. Based on the data and what we have learned in this module, do we have sufficient evidence to claim that women are being discriminated? As we have discussed in Module 3, we are 95% certain that the true mean is in the range of mean plus minus 2.06 times standard error, which gives us a 95% confidence interval at £59,613 to £65,541. Because the mean salary of the men is £66,300, which is larger than the upper bound of the confidence interval, we can then accept that women are being discriminated on salary based on our sample. This case shows that we can also use confidence interval to conduct hypothesis testing. However, it is only good for two-tailed testing. In other words, we cannot use confidence interval for one-tailed testing. For this female salary case, alternatively, following the 6-step procedure, we have step 1, we state the null hypothesis H sub 0 mu equal to 66,300. The alternative hypothesis H sub 1 mu not equal to 66,300. Step 2, we note that the level of significance is alpha equal to 0.05. We also know that the sample size is equal to 26, so we have a degrees of freedom equal to 25. Step 3, because we do not know the standard deviation, we are going to use the t-test for this hypothesis testing. Step 4, we formulate the decision rule. As we already know, after checking the t-table, the critical values are given by the positive 2.060 and negative 2.060. Step 5, we calculate the t statistic as follows. T equal to x bar minus mu over s divided by square root of n equal to 62,577 minus 66,300 over 1,439, which is equal to negative 2.59, less than negative 2.056. Because the t statistic negative 2.59 is inside the rejection region, we have sufficient evidence to reject the null hypothesis. Step 6. In conclusion, we can accept the claim that women are being discriminated on salary based on our sample. In this video, we studied the hypothesis test for the mean with unknown standard deviation. T-test has been widely practiced in hypothesis tests and very useful. In this video, we have specifically discussed one-tailed t-test and two-tailed t-test and revisited the confidence interval for the two-tailed testing of the female salary case.